So what we're going to do today is talk about making graphs out of observations. So basically making a table and a graph. For this set of data we're talking about time and temperature that will fit the following information about a day riding your bicycle. So there's a couple of statements here, and they all have some kind of clues within them that are going to give us some numerical data that we're going to be able to put into a table and then afterwards create a coordinate graph with that data. So we're going to want to put that data in our table. If you keep reading, it says the day was quite warm with dark clouds in the sky. And that's important because it describes our temperature, and we're thinking about temperature during the daytime, and warm temperature is about 70 degrees, but when we think about having clouds in the sky, that kind of blocks the sun and affects our heat index. So I would say the temperature is less than 70 degrees. It's about 65 degrees. So as we move on, the next statement that we have says about mid-morning to me means, if we start the day at 8 a.m. for the bike ride, lunchtime is about noon, which they refer to as midday. So mid-morning is approximately 10 a.m. So mid-morning at 10 a.m. it says the temperature dropped quickly to 63 degrees, which is very obvious that that is a piece of data that we're going to need. And then it says there was a thunderstorm for about an hour. So that brings us from 10 a.m. to 11 a.m. and from 63 degrees and maybe even down to 60 degrees as a thunderstorm, the rain from the thunderstorm cools the air temperature surrounding the biker's trail. So after the storm, the sky cleared and there was a warm breeze. After the storm, I would say an hour after the storm, around noon, the sky cleared and there was a warm breeze. Now, midday, around noon, when the sky is clear, it can usually heat up pretty quickly. So I'm going to say the temperature has jumped to about 70 degrees. As the day went on, the sun steadily warmed the air. Now, steadily is very important here. And it says, when we reached our campground at 4 p.m., it was 89 degrees. 4 p.m. and 89 degrees. This is important. We're kind of working a little backwards here now because at 4 p.m., it was 89 degrees. That's where we're finishing our bike ride. That should be our last data point that we have. But what we need to do is we need to fill in the information in between that time. So at 1 o'clock, at 2 o'clock, and at 3 o'clock, we need steady increments of time in between 12 and 4 that will have the temperature rising at an even level, continuous, even field. So what we need to do is figure out what is the temperature between 70 degrees and 89 degrees? How many degrees do we have to travel to increase our temperature? So we're going to do 89 minus 70 equals 19. And we're talking about this increase of temperature within 4 hours. So we're going to want to divide 19 by 4, or approximately do that. And we know that 4 goes into 19 4 times, but we also are going to have a remainder of 3. So for our first 3 time slots, we're not going to have a 4-degree increase. We're going to have a 5-degree increase to account for those extra degrees. Even though we're not completely dividing, this is an approximation, which is pretty good. So from 70 degrees, we're going to go up 5 degrees to 75. And then up 5 degrees to 80, and then up 5 degrees to 85, and then that last interval is only up 4 degrees, but it is a pretty even interval all the way up to 89 degrees at 4 o'clock. And that's what that means by a steady increase, that you increase the same amount until you reach your final point that you're looking for. So now that we've got our data table, we're going to start looking at our graph and plotting our coordinate points and reviewing the data that we've collected. So the day starts at 8 a.m. We're looking at mid-morning. There's a thunderstorm that lasts an hour, and then our finishing point at 4 p.m. and a steady increase from 12 to 4 p.m. in the temperature. When we look at temperature, we know the day was warm. There's clouds in the sky, so we started the temperature a little lower than maybe as warm as you would think. The temperature drops to 63 degrees. Then we have to account for the thunderstorm and the sky clearing and the breeze being warm. And then, of course, the steady increase of temperature to 89 degrees. So as I look at my coordinate graph, I need to have my axes in the right spot. Time is always on the x-axis. That's our dependent variable, so we know that that's the case. And we have temperature along the y-axis. Now the scale for my time I put at an hourly increase, and the scale for temperature I did in increments of 5 degrees. This again is a personal decision, but you may label your graph however you choose in your notes, or you may label it just like I did so that you can follow along. So as soon as we're set, I'm going to get myself 2 lines to guide where I'm going to plot my points. And the first point that I'm plotting is at 8 a.m. and it's at 65 degrees Fahrenheit. So I'm going to plot that point. The second point that I'm plotting is at 10 a.m. and it's at 63 degrees Fahrenheit. My third coordinate pair is at 11 o'clock and at 60 degrees Fahrenheit. My fourth coordinate pair is at 12 o'clock and at 70 degrees. My fifth coordinate pair is at 1 o'clock and 75 degrees. And then my next coordinate pair is at 2 o'clock and 80 degrees. The next one is 3 o'clock and 85 degrees. And the last one is at 4 o'clock and it is 89 degrees. Now, one of the important things to think about when we want to check our work or take a look at our graph is that those last 4 data points should be increasing at a steady rate. So from 12 o'clock to 4 o'clock, we should be able to draw a straight consecutive line through those points to show that they're increasing at the same rate. That means that the same amount of time is passing as the same amount of temperature is increasing between 12 o'clock and 4 o'clock. And as you can see, we can draw that straight line right there, and it is true that we've plotted those points correctly. Now if you want to connect the rest of your dots, you may. You don't have to. It's not necessary for a coordinate graph, but it's personal preference as well. And since there's time in the x-axis, you do have that option. Okay, so this was a little lesson on how to make graphs out of textual observations instead of just data tables. And the work that we'll be doing on Tuesday in class will have a lot to do with this. So make sure your notes are complete, and I will see you next week.